Oh, the solar system places you'll go. Our solar system is wild and exciting, and after decades of exploration, we were sure we had it pegged. However, the last few years of observation and space missions have taught us that what we thought we knew is something completely different, as a Monty Python might say. So let me take you quickly through our solar system. This is our solar system. We start close to the sun, terrestrial planets, Mercury, Venus, Earth, Mars, zooming through the asteroid belt, going by Jupiter, Saturn, Uranus, and Neptune, with comets and asteroids and moons to follow them, out to the edge, more or less, where the Kuiper Belt resides, with Pluto as its main example. Now, our solar system is fine-tuned today, but it hasn't always been like that. When we look at the geology, the physics, and the chemistry, we start figuring out that throughout its evolution, things have changed. It didn't just hatch into existence, did it? It was messy in the beginning. Some things happened, some things connected and disconnected. And we explore all this, driven by inspiration, to boldly go where no one has gone before, yes? To acquire knowledge, can we sail beyond the edge? How can we decipher what the heavens tell us? Inspiration and knowledge come together to give us some sort of understanding of what happens around us. We call it context. The physics, the basic chemistry tells us how the universe is built in larger and larger scales, how you build galaxies, stars, planets, and eventually life. We gain some understanding about this context, and of course, we move on to explore. Take notes of all of these. There will be an exam at the last 20 seconds of the talk. No, really, we've been exploring the solar system for quite a while now, and obviously I don't have time to go through everything. So I'll just give you a few of the highlights of the more bizarre and interesting things that I find in solar system science today. We start off closer to the sun with Mercury. We all know that Mercury is desiccated and it's dry. NASA's Messenger spacecraft has recently observed water ice patches in the North Pole region and shaded craters, and magnificent chemical diversity across its surface. Not so dead, is it? Next, after Mercury, comes Venus. Venus is volcanically active today. We see that by a myriad of observations. There is a spike in atmospheric sulfur observed by the Venus Express mission, bright hotspots on the surface that come and go, and reflectance that seems like a young lava flow on the surface. After Venus comes Mars, and we see here the newest Curiosity lab robot on the surface, roving on the surface, and it takes a selfie here, and behind it we see what looks like flood basins. These mineral veins in the smaller image are evidence of a wet and flowing environment. These are crucial for life. Beyond Mars is the asteroid belt. And here we caught a little guy kind of red-handed. This has been observed by the Hubble Space Telescope. It took a shot of its amazing debris field and its weird X shape. It's a result of a recent collision with another small object. Next, we go further and we encounter Vesta, the second largest asteroid and the first target of NASA's Dawn mission. Vesta is a stripped-down larger asteroid. What you see here is a core, stripped by a massive collision, followed by multiple other impacts that cause these craters and troughs. Beyond Vesta lies the heavyweight of the asteroid belt, Ceres. Ceres is a completely interesting world in its own. It harbors patches of water ice that promote vapor, haze vapor above its surface, and this weird-looking volcano with ice covered on its surfaces. This is a comet. Yes, this is a comet. This is a target of the European Rosetta mission, and it's been hovering about 30 miles above its surface, taking amazing pictures at a 50-meter resolution. What we see here are patches of ice intertwined with fluffy dust fields and very porous boulders. If we go beyond Jupiter's orbit, we encounter the Centaurs, cold asteroids in the outer solar system we thought are dead. They don't do anything at all. However, we found around 2 of these objects ring systems. Ring systems are objects that are no more than 100 kilometers across. We don't know how the rings are made of. Next, we encounter Europa, one of Jupiter's largest moons. It is covered with a rock-hard ice layer dozens of miles deep, and underneath it, a living, warm ocean. And we see that observing plumes of water ice creeping out through the cracks on its surface. Beyond it, around Saturn, orbits the largest moon in the solar system, Titan. It's a smaller, cryogenic analog to Earth. It has a thick atmosphere. It has seas, lakes, sinkholes coming and going in a periodic manner, but not of water ice, but rather methane, nitrogen, and ethane. Last but not least is Pluto. Pluto has been a speckle of light, and it has now just recently become a new exciting world. It harbors ice mountains as tall as the Rockies, plains of nitrogen ice, all encompassed in its heart, Tombaugh Regio. Pluto's accomplice, Charon, probably sports the weirdest feature that I have seen to date in the solar system. It's a mountain, kilometers high, in a moat, in a chasm deep on the surface. Obviously, this is not a dead, cold rock. It's an active, living world that has changed. What else can we find when we keep digging in the data? So I would just like to iterate our notion of exploration. We look up, we look beyond, we use telescopes, we send people to the moon, or maybe to Mars even. We are driven by inspiration, knowledge, and the context that it gives us about our life and our close neighborhood. And I'll finish up, let's be honest, we're interested in the mundane things. Yes, we've explored the solar system, and that's it. But if we look up from our Wi-Fi from time to time, we may be able to ask ourselves just a simple question. Where will we go next? Thank you.